Hello everybody, this is Dr. Fouladian and I'm going to start explaining about osseous tissue and bone structure related to the skeletal systems. So that's the chapter 5 of the book Martini, and just as an introduction, the skeletal system is made of skeletal bones and also the cartilages, ligaments and connective tissue that all is helping to connecting the bones together and stabilizing the skeleton. Bones are dynamic organs, and it means that this is not a specific shape that is not changing, it's growing. We have repair of the bone, we have the effect of the pressures of the bones, fractures, and all those ones that we are going to explain just from the beginning. Pay attention that those are dynamic organs and the other things, the surrounding environment and everything can affect them, which consists of the several tissue types. So pay attention that getting back into the level of the organization, we have bone tissue as a type of the connective tissue that you already have seen in the connective tissue, and here in this chapter we're going to talk about that in more detail. Sorry. To get look into that more closely, what type of tissue it is, what are the components, and all those things. Then we have several types of the tissue together makes the bone as an organ. You remember, an organ has a specific shape, like a bone of like for example, a long bone that you have in the arm. We name it as a humerus, right? So it has a specific shape. We call it a specific name, and is composed of several types of the tissue, including the bone tissue, other type of connective tissue, like for example, it may have some blood vessels inside that, it has some nerve inside that. So you will see that all types of other tissue all together, that are like the epithelial tissue in the blood vessels, like the neural tissue as I mentioned, and all these ones make the bone as an organ. And then all bones together, they are making these bones as an organ with the other organs that just we mentioned here, like the cartilage and ligaments. Sorry. These are all other organs of the skeletal system. All these organs together, they are making a system, a skeletal system. So please pay attention to the level of the organization, and at each moment we may talk about, in this chapter we may talk about the bone as a tissue, and then we may jump over the bone as an organ. So we differentiate these ones, which one we are talking about. So a skeleton, that's the collection of all the bones that we have in the body, is divided into two divisions: axial skeleton and appendicular skeleton. Axial skeleton is the one that is in the center of the body, that we have the head and neck, and also the trunk part. All the bones that we have in these areas are making the axial skeleton, as referring to all the skeleton that we have in the axis or center of the body, in the longitudinal axis of the body, right? Then we have appendicular skeleton, all the bones that we have in the upper limbs, and including the ones that are connecting the upper limb to the center or to the axial skeleton, and also all the bones of the lower limb, and including the bones that are connecting the lower limb to the axial skeleton too. So the function of the skeletal system as a system supports, that's the support, and there are more in the next slide. So regarding the support, provides the framework for the attachment of other organs. Like these are the deepest structure of the human body, right? Over there we have the muscles that are attaching. Between the muscle, all the blood vessels, nerves, and everything is running and leading to their destinations, right? So this is the one that are making the main framework so that all the other organs can have a place to attach and be connected. They are a place for the storage of the minerals. Calcium ions, for example, 98% of the body's calcium ions are in the bones. Where's the other 2%? That's inside of the blood vessels, right? Because what the body is using in chemical reaction is the ions of the calcium. So 98% of them store in the bones. Only 2% are the amount that we need for all the chemical reaction that we need. We will see that calcium ions are very important in the muscle contraction. So all the muscles that we have in the body, all other functions of the body, all movement of the body are by the muscles, right? Including a locomotion, that are the moving of the skeletal muscle, or heart. A heart is another muscle, is dependent on the calcium ion, right? So the movement of the heart is dependent on the calcium. All the small muscles inside of the body, the movement of all the internal organs are dependent on the calcium ions. So we have 98% of all the calcium ions in the bones. So whenever body needs that inside of the blood, these ones can get separate from the bones and get into the blood due to some hormonal reaction and many other reactions that we may learn about them more later. So besides calcium ion, for example, phosphate ion is another ion that stores in the bone. The other functions of the skeletal system: blood cell production. It might be surprising, right? You may think that the blood cells are belonging into the blood, and blood is part of the cardiovascular system, therefore the production of them should be part of the cardiovascular system. But surprisingly, it's not. It is done inside of the bone marrow that we have inside of the bone, in the middle of the bone, that they're producing erythrocytes, red blood cell, leukocyte, white blood cells, and platelets. Besides that, leverage that the muscles pull on the bone to produce the movements, the skeletal muscles. Protection. Ribs protect the heart and lung. So we have many cage, like the shape that we have a bony cage actually in different parts of the body. For the heart and lung, we have the ribs that are protecting. We call, as we discussed about that, we call it thoracic cage or rib cage. For the skull, that protect the brain, vertebra that protect the spinal cord, and pelvic bones that protect the reproductive organs. We already have seen these parts and we have talked about these ones. So those were just the main functions of the skeletal system as a whole system, right? Now getting back to the level of the tissue. So we said that the bone as a tissue is a connective tissue, right? So let's talk about that more. As we name the bone as the osseous. Osseous tissue means the bone tissue, a supporting connective tissue that its matrix, in the matrix of the bone, we have calcium phosphate. The calcium phosphate eventually converts to the hydroxyapatite crystals, the crystals that are hydroxyapatite. These hydroxyapatite crystals are resisting the compression. And this is the one that makes the bone so hard and solid and in most cases unbreakable, right? And this calcium phosphate makes about 2/3 of the bone mass. So most of the bone mass are this calcium phosphate, and that makes the matrix very solid, right? Then besides these calcium phosphate, we have collagen fibers that make about the other 1/3 of the bone matrix, and these are contributing to the tensile strength of the bone so that it is not loose or flexible. It gives that the tensile strength so that it cannot be pulled or get separated from the both sides. And these two, collagen and hydroxyapatite crystals, makes bone tissue strong, right? Now, only about 2% of the whole of the bone mass, it comes from some cells that we have inside of the bone. We call them bone cells. So pay attention to what all is the whole bone is made of as a tissue. Now we're going to talk about bone cells more. What type of cells we have inside of the bone. The same way that we talked about, like for example, connective tissue proper, that they have a specific cells, like we said, fibroblast, fibrocyte, macrophages, this and that. Now we are going to talk about the specific cells that we have inside of the bone tissue. In general, we have 4 types of the cells in a bone, right, in general. Now, the first one that we're going to talk about is osteocyte. You remember that the cyte means cell and osteo means bone, refers to the bone. Osteo, osseous, all these ones refer to the bone. So this is the cells of the bone. And these are the mature cells of the bone. When the bone cells get mature, we call them osteocytes. They maintain the protein and mineral content of the matrix. So the role is the maintenance. When the cells, the bone cells get mature, then after that, these cells are maintaining the protein and mineral content of the matrix. They sit in a depression called lacuna. There's a tiny space around each osteocyte that we call that lacuna. The same way that we thought that we have the same and space around the chondrocytes in the cartilage, and we talked about that over there, the lacunas are bigger. We have the same in the bone too, but in the bone, this space may not be very big, but it still exists. Then the matrix layer associated with osteocytes is lamella. The matrix that we have in the bone is layer by layer by layer, one after another, right? And we call those layering. Each layer is called a lamella, right? And if you want to talk about more than one, we put an E at the end and we call it lamella, right? So we have a small channel that extending from the osteocytes to the bone capillaries, and they are called canalicular, means little canal, right? Now let's go see all these ones. After I explain all these 4 types of the cell, I'll show you the picture. The other types of the cells in the bone that we have, it is osteoblast. Osteoblasts are immature bone cells. Those immature cells found on the inner and outer surface of the bones, because these are the cells that are going to produce osteoid. Osteoid is involved in making the matrix, right? So osteoblasts are producing osteoid, and osteoid are making the matrix. So as you see, these cells are producer of the matrix compared to the osteocytes that are maintaining whatever we have in the matrix. Now, osteoblasts are involved in making new bone by making of the new matrix, and this is a process called osteogenesis. Genesis in general means producing, generation, right? And osteo again means bone, so osteogenesis is a process of the bone formation, production of the bone, right? And one part of that is our osteoblasts. Osteoblasts that they are making the matrix, and through that one making new bone, right? Pay attention that these osteoblasts that are immature bone cells, they are like, imagine you have an osteoblast and they are producing osteoid outside and give it out, and that osteoid makes the matrix outside, more and more, until there is no more space around for the more matrix. No more matrix can be produced, and in this way, that osteoblast is trapped among all the matrix that has made around it, and there is no more space around to make more, right? At that point, that osteoblast changes to osteocyte, and osteocyte now is a mature cell, is not able to produce more matrix. It just maintains all the matrix that we have. And it is actually the way that around the osteocyte, you have a teeny, just a space that we call it a lacuna, because the cells have been trapped in the space that was free before and now has been confined with a tiny space, and all around that you have a matrix. Isn't that beautiful? Yes. So that was the two types of the bone cell. The third type, it is called osteoprogenitor cell. Progenitor is like an ancestor, right? These are an ancestor bone cells, that they are actually bone stem cells. What does it mean? They are found in the innermost layer of the periosteum and the inner lining of the endosteum. So these are the two places that the bone growth is happening. You remember, periosteum is the outer layer of the bone. Every single bone has a periosteum around that. And if the bone is going to grow, like during the growth of the baby, the bone is going to grow, right? And it's one place that is happening is from the outside in the layer of the periosteum. And now you see that we have the osteoprogenitor cell. And remember that in the previous slides we said that we have osteoblasts also in the inner and outer surfaces of the bone too. Osteoblasts are making the matrix. What are they doing? Osteoprogenitor cell. They are actually getting divided. They are stem cells. They get divided, go under mitosis, and produce more and more bone cells. And in this way, they make the growth of the cells. So besides the periosteum, there are outer of the bone. In the inside of the bone, if, for example, if it is a long bone, that it has a cavity inside of the bone, also we have a lining that we call it endosteum. Endosteum, right? Inside of a bone. Osteum means bone, right? So inside of in the lining of the endosteum, also we have these cells. So you see that in the periosteum and in the endosteum, we have osteoprogenitor cell producing more cells, and also we have osteoblasts that producing more matrix, and this is the way that the bone is growing from inside and outside, right? Now, they differentiate to form new osteoblasts, right? When those ones, stem cells, start to produce more cells, they differentiate to form the bone cells that they are the first line after them is osteoblasts. And they're heavily involved in the repair of the bones after a break. So you will see that repair process is very similar to the making new bone. So by making the new cells, they are involved in the repair process after a break. So as you see here, these three cells, osteoprogenitor, that are stem cells, they are making osteoblasts. Then osteoblasts are making matrix, and finally osteoblasts become osteocyte. So as you see, they're coming one after another. They are all in the line of production of the more cells and more bones. Comparing to the fourth type of the cells that we have in the bone, that we call it osteoclasts. Osteoclasts are different from all those three types of the cells, that they are not producing more bone as a bone cells or bone matrix and the whole bone tissue. They are multinucleated cells, and it makes it easier to recognize. They are bigger than the other cells and multinucleated. Sorry. And they secrete some acid which dissolve the bones, thereby causing the release of the stored calcium ions and phosphate ions into the blood. This process is called osteolysis, means lysis of the bone, right? So as you see, all the other three were taking part in osteogenesis. These osteoclasts are taking part in the osteolysis. But pay attention, in many processes of the body, the osteoclast that lies in the bone sorry, are working hand in hand with all those osteogenesis groups of the cells. In one location of the bone, you may have the osteoclasts are lysing the bones, and on the other end, you may see that the osteogenesis groups are making new bones, and all these ones all together take part in a process that, for example, in the repair of the bone, or sometimes in a process we call it remodeling, but later we're going to talk about that, like it happens due to many dynamic parts of the bone and development and repair and all those things that may need that some parts to be dissolved and some new parts may be formed, and all these ones working together like a construction group, that some of them are destroying some part and the next group comes and makes the new material over the destroyed parts, right? So these are all working together. And one other thing, pay attention that these osteoclasts are I don't know what happened to my for today. That sorry about that. So osteoclasts are important, and they have an important jobs to just maintain the concentration of the calcium ions in the blood, because whenever that goes down in the blood, we said that we have the storage of the calcium ion in the bone, but we need a way to release them, to push them into the blood, and that's the job of osteoclast. And later you will see that many hormones are affecting these osteoclasts and make them, give them a signal to start working, to just break all those parts of the bone and release the calcium ion into the blood, right? So these were the four types of the bones that we have inside of the cell. And here you're looking at a small parts of a long bone. This is the inside of the bone, but later I will show you that we have a cavity and it is around that cavity. And this is the wall around of that tube like of inside. Now we're looking at the one small part of that. You see that we are going to talk about the 4 types of the cell that in different parts. Later we're going to talk about all the structures that in this bone that is actually compact bone here in more detail later. So here you see the 4 types of the cell that we have here. The first one that you can recognize very easily are these osteoclasts that are very big. They are multinucleated, and then after that we have osteoprogenitor cells, like here have been shown from the inside. This is endosteum of the bone. In the outer layer we have periosteum of the bone. We have them in both places, but here have been taken from this one. So these are osteoprogenitor cells, right? Then they make the osteoblasts. They differentiate into the osteoblast here, and those osteoblasts start to making osteoid, and these osteoid are going to make the matrix of the bone here. And finally, these osteoblasts, after producing so much matrix around themselves, they make the osteocytes here, right? So pay attention that between the osteocytes, between the 2 osteocytes and between them that we have some capillaries here, we have some tiny canals that we call it canali that have been shown here. Right, you see them. And here you see that all these cells, these are osteocytes here, that they are around the layers. Each layer here, like this layer, the whole layer is called a lamella, altogether lamellae. But you see you have layer by layer, right? So, and other things that this is a specific structure of the compact bone that you see. This is like a circle, like a cut of a tree that you see. You have a center that we call it central canal. That's the place that the artery, vein, and nerve for the bone is passing through that, like here. This is one structure here, and inside of the central canal, you see you see the cut section of that artery, vein, and nerve for the bone is getting into each one, and each one of these is called a osteon or Hoversian system. We have it in all the next slide. I just wanted to show you the picture here, and you see that you have one here, one next to that, one next to that, all after another. And the other things I wanted to show you here, just you see that you have the lamella in different levels, that you have some lamella here around the whole bone, you have some lamella here in the osteon or Hoversian system, and you have some lamella between them, between the osteon, like this one, and this one, and we're going to see them, and you see that each one has a different name just because of the name. So for the type of the bones, we have 2 types of the bone in general. Compact bone, another name for that is dense bone. The one that I just showed you was a compact bone. The other type is a spongy bone, that is also called trabecular bone or cancellous bone. Oh, this one is extra. And now compact bone are dense and solid, as I showed you, and form the walls of the bone. So in general, every single bone of the body, no matter what type of the bone, what shape or whatever, it has one layer of the compact bone around the bone. Then we have a spongy bone that's called trabecular or cancellous bone. They are like open network of the plates, and they form the epiphysis. Later we're going to talk about that. When we have a long bone, the true end of that is called epiphysis. So most of those parts are made from the spongy bones. And they are surrounding the medullary cavity. Again, when we have a long bone, in the middle we have a cavity like a tube that we call it medullary cavity. You remember, medulla is the center, deep part of anything, right? So we call it medullary cavity because it's just located exactly in the center, the deepest part inside, right? Medullary cavity. Around that cavity is lined by a spongy bone, one layer of spongy bone. And medullary cavity consists of yellow bone marrow. So inside of that cavity we have yellow bone marrow. So I will explain here and then we see the pictures. So for the structural difference between compact and spongy bone. Compact bone consists of the osteum, as I showed you, that we call another name for that Haversian system, those round structures that are layer by layer around the central canal. And those osteons are basic functional units of the compact bone. It consists of the central canal in the middle, canalicular, osteocytes that I showed you, lacuna, the space around each osteocytes, lamella, that we have concentric lamella. The concentric lamella are inside of the osteon, that they are around the central canal. They are concentric, right? We have interstitial between the osteons, and we have circumferential. Those are the ones that are around the whole bone, right? As I showed you. And we have some perforating canals. Those perforating canals are the ones that when blood vessels want to get inside of the central canal, they just transversely pass through to get into the central canals. Here in this picture, you see those parts, like you see a long bone here that it has lots of blood vessels here. And you see that the outside of the bone, you have one layer of the compact bone all around everywhere. But you see that there is a thicker in this middle part, that is a shaft of or body of the long bone. Then you see the spongy bone here, that is called trabecular bone. And you have it in this upper part, that is, we call it epiphysis of the long bone, and also the lining inside of this medullary. This is a medullary cavity and is lined by one layer of the spongy bone here too. So pay attention that, as I mentioned, every part of the bone and every single bone is covered by one layer of a compact bone outside, then inside has a spongy bone. But the only thing is that what's the proportion of the compact bone to the spongy bone? Like here, you see that the most of the bone is composed of a spongy bone. It has a thin layer of a compact bone around that. Therefore, we call the epiphysis mostly a spongy bone. And regarding this body part of the bone or shaft of the bone, that the thick layer of the compact bone compared to a very thin layer of the spongy bone. Therefore, it may be called that the body of the long bone is composed of a compact bone, as you can see that here, right? So that's the proportion that you don't get surprised if you hear or see that the body or the shaft of the bone, long bone, is a compact bone, and the epiphysis is a spongy bone. That's the U2, that's bone. But you always remember that the outer layer of every part of the bone is compact. And here again, you see the structure of the compact bone under the microscope. And we talked about all these ones: central canal, all these osteocytes, all these canalicular, tiny connections that we see between the cells and the capillaries, the tiny blood vessels that are passing by. And that's the way that the osteocytes gets the nutrition. And all these layers, each one is called the lamella, all those ones, right? And pay attention to the concentric lamella. These are all concentric lamella inside of a stone between, so between the, like this is one osteon, this is another osteon, this is one osteon. Between them here you have interstitial lamella, and around the whole bone you have the circumferential lamella. So regarding the spongy bone, the structure of a spongy bone, they are arranged in parallel struts like this. You have also lamella on those ones, but they are not around a central canal. In another word, we do not have a central canal in the spongy bone, so that's the first difference. But still we have lamella, and the cells osteocytes are arranged in lamellas, right? They form branching plates called trabecula. So you have the lamellas going, a bunch of them in this direction, the other one goes in this direction, the other one goes in this direction. Like a tree that has thousands of branches and they are connecting to each other, right? We call them trabecula. Trabecula form an open network and create the lightweight nature of the bone, because compact bone is a heavy part of the bone. Spongy bone, because of all these spaces that we have between the trabecula, is the one that making the lightness of the bones. As you see here, this is one trabecula, another trabecula, another trabecula, I've been named as this chart here. So you see that between the trabecula you have some empty space like here and here. When you look at the structure of each trabecula, although the cross section may looks like round or oval, they are in, as you see, they have lamella layer by layer, they have osteocytes, they have canaliculi, they have all those things, but they do not have a central canal, and the blood vessels doesn't pass into them, and the other things that they do not have osteum. So those are the only differences, right? But just pay attention, inside of these spaces here between the trabecula are they all filled with the bone marrow, but here we have red bone marrow. Red bone marrow inside of the spongy bone. And as we already talked about that, bone marrow, red bone marrow is the source of all type of the blood cell productions. So whenever we need some stem cells for the blood cells, we have to take them from the red bone marrow. And where in the body we can find those red bone marrow? Inside in the space of between the trabecula of the spongy bone. And later we're going to talk about them. In some parts of the body is more accessible, where they are more closer to the surface. For example, like at the hip area from the ilium, that we can just put a needle into these spaces and draw some of the bone marrow and then do whatever they need to do with that to transplant them. So, and here you see the canaliculi opening on the surface here, and they get the nutrition from all the material that they have inside of these spaces. So we have some functional, besides all the structural differences between compact bone and spongy bone that you need to know completely in detail, we have some functional differences that they are more detailed. We do not have time to go into these ones, and that's not needed for your course, but you still can go over there. I left them here. If you are interested, you can go and read those ones. And also this picture is showing the alignments of the collagen fiber and all those ones, and that's regarding the functional differences between the compact bone and spongy bone. And also you can get more from your book too if you are interested. Now regarding the compact and spongy bone. The other thing that we have for the long bone. In many parts of the body, we have long bones. Long bones are the ones that their length is more than their width, right? Like, for example, in the humerus is a long bone. Right now, you know the name of the bones, right? Humerus in the arm is a long bone. The two long bones that we have in the forearm, radius and ulnar, femur, that's the longest and biggest bone of the body, tibia and fibula, even all the metatarsal bones, all the phalanx bones, right? All those ones. In the, also metacarpal bones, and also all these in the phalanx or metatarsal bones in the foot, all those ones are long. And in general, each long bone has a specific structure. It has two ends. Each end is called epiphysis. Sometimes you may see that we may call it, to differentiate these two, we may call the one that is closer to the center as a proximal epiphysis. The one that is further from the center of the body, we call it distal epiphysis, right? And they consist of red bone marrow or red marrow, as we said that most of these epiphyses are composed of the spongy bone or trabecular bone or cancellous bone, right? Then in the middle we have shaft of the long bone, shaft or body, that we call it diaphysis. So diaphysis has a cavity inside, we call it medullary cavity, as I have shown you already. And that one consists of yellow marrow. So pay attention to where do we have yellow marrow, that is in the medullary cavity, where do we have a red marrow, that is in the epiphysis of the long bone or other spongy bones over the body, even they may not be a long bone. And regarding the diaphysis, if the shaft breaks, diaphysis breaks, a fracture will occur in the long bone. And although we may have fracture on other parts of the long bone too. And then we have another part, we call it metaphysis. Meta in general means in between, in the middle, right? So metaphysis is located between the epiphysis and diaphysis at the two ends. Each epiphysis in any end and the diaphysis. So we have two metaphyses too. The narrow growth zone between the epiphysis and the diaphysis, and this is a growth zone because the growth is happening in this area, as we're going to talk about that more here. So here you see those parts, epiphysis, that is this part, and you have diaphysis here, the whole area, and then you have another epiphysis, and this area between epiphysis and diaphysis in the two ends is called metaphysis. Now regarding the periosteum and endosteum, as we already talked about a little bit, periosteum is outer surface of the bone and it consists of the two layers, a fibrous layer and an osteogenic layer. That osteogenic layer, that's the one that is composed of osteoprogenitor cells. And isolates and protects the bone from surrounding tissue. That's the functions, provides air route and a place for attachment of the circulatory and nervous supply. When they want to get inside of the bone, they have to pass through that, actively participate in bone growth and repair because of all those osteoblasts and osteoprogenitor cells, and attaches the bone to the connective tissue network of the deep fascia through the perforating fibers. So let me show you these perforating fibers, but just here pay attention that these are perforating fibers, these are just some fibers, and differentiate them from the perforating canals that we have, right? And let's see this endosteum, and then we go to the picture. Endosteum, as we thought, they are inner surface of the bone, lines the medullary cavity, and consists of osteoprogenitor cells too, and actively involved in the repair and growth of the bone. So here again, you're looking at the one part of the long bone here. You see the compact bone around here, and you see the periosteum in the outer layer of the bone. That you see that you have a fibrous layer around, and then you have the osteogenic layer here that is inside of that. So fibrous layer is outside, osteogenic layer is inside, and then on the right you have all compact bone, and then you have the spongy bone, and you see that all those ones are covered with the endosteum. And if you look at the periosteum in more at a closer look, you will see that you have a fibrous layer here outside, you have an osteogenic layer inside, and you see all the compact bone here, but I don't see those perforating fiber here. As soon as I see in a picture, I will show you, but they are locating here, connecting between these and the compact bone here. Very thin, tiny fibers here. We call it perforating fibers. And the other name for them is Sharpie fibers, if you ever hear them. And also regarding the endosteum, also you see that you have all those osteoblasts that making osteoid and osteoprogenitor cells. They have both of them in the endosteum too, and therefore they are able to take part in the growth and the repair of the bone too. Now regarding the bone development, up to 8 weeks of development, the skeleton is hyaline cartilage. Then after that, so this is regarding the development of the long bones, right? Let's talk about all the bones, and then we go over the different types of the bone development. So at the beginning, we have the skeleton is in the form of a cartilage, hyaline cartilage. So at the very beginning, we don't have the solid, dense structure of the bone as the way that you have in an adult or even in a baby, right? They are from the hyaline cartilage. Then fibrous tissue and cartilage cells will be replaced later after the 8th week by the bone cells. And this process is called ossification. So when the cartilage changes to a bone, it becomes ossifies. And that's the process that we call it ossification. It means becoming bone, right? Ossification. Now we have two types of ossification, intramembranous ossification and endochondral ossification. In intramembranous ossification, bone is formed from the fibrous tissue, and in endochondral ossification, and you all know that the chondral means related to the cartilage or chondrocyte, bone formed from the cartilage tissue. So that's the main difference between these two types of ossification, intramembranous and endochondral ossification. Now, we have other terms, osteogenesis, the process of the bone formation. So it is, pay attention that we had osteogenesis and osteolysis before, so you know these ones. Osteogenesis is the process of the bone formation when the bone is formed as a tissue. Ossification means that when the bone is, when one structure from a cartilage changes to a bone, right? And we have other term, calcification means when the calcium is deposited into the calcium ion deposited into the bone tissue and makes it solid, right? So these are just tiny differences between these ones. So pay attention to the key points that differentiate them from each other. So as we said, we have two types of ossification, intramembranous and endochondral, and you need to know that which parts of the body have been formed during each process. So intramembranous ossification that they come from the fibrous tissue involved in the development of the clavicle, mandible, skull bones, and the face. So most of the skull bones and the face are coming from the intramembranous ossification, and also including the clavicle and mandible. And the chondral ossification, on the other hand, involving the development of the limbs, that most of the bones over there are long bones. Vertebrae, that they are irregular bones that we have, each vertebrae, and also the hips. And in general, you can say the rest of the body. Whatever is not intramembranous is coming from the endochondral ossification. So this one's it shouldn't have been gray because that's part of the course that you need to know actually. So as we talked about where the coming intramembranous ossification, the parts that making through the intramembranous ossification. Now the process is that we said that intramembranous ossification is when the cartilage changes to the fibrous. The bone is coming from the fibrous tissue, right? We have mesenchymal cells that they are, as we talked before when we were talking about the connective tissue, that they are the main ancestor of all types of the connective tissues, right? Those mesenchymal cells differentiate to form osteoblast. Then osteoblast begins secreting a matrix and all the other things that we discussed. Then they become osteocytes. Then they trap into their matrix and differentiate and form osteocytes, and more osteoblasts are produced. Thus move outward, right? And the blood vessels are trapped by the formation of the spicules. You don't need to know the name, just know that in the process, any new tissue that is forming, we have the ability in the body, we call it angiogenesis. Angio means vessel, like angiography, graphies of the vessels, right? Angiogenesis is the ability of the body to produce new vessels wherever a new tissue is forming to support the new tissue, right? The same is here. When the new bone is forming, new vessels are producing inside, and also they're trapped in their formation of the new bone in the middle. Just a detail about that. So as you see here, intramembranous ossification starts from the differentiation of the mesenchymal cells into the osteoblast, and then osteoblasts become osteocytes and continue to become a bone. Later you will see that in the endochondral ossification, first a cartilage is formed from mesenchymal cell. Then that cartilage becomes ossified and makes the osteoblast and the osteocytes and other things, right? So here in these pictures, you don't need to know the detail, just look to see that what's going on. You see the skull and mandible, they come through there, and also clavicle if you had it here. These are mostly flat bones or irregular bones that are coming from the intramembranous ossification. And as you see, you have a matrix here that around them you have all these cells of these are called the ossification center, and you have the osteoblasts that they are making the matrix in the middle. Then you see that in the next picture they are getting bigger, more matrix, and finally as the shape that are making like the spicules, and those blood vessels that you have it around them, now they are trapped in the middle of them, and this is the way that finally those mature cells become osteocytes, and that's the way that at the very end you have all those spongy bone has been formed and all those blood vessels that have been trapped inside of them, right? Just know this much, you don't need more detail about that. Then regarding the endochondral ossification, that as we said is involved in the development of the limbs and vertebral column, and chondrocytes near the center of the diaphysis increase in size. I will show you the whole process here. Blood vessels begin to grow around the cartilage, and we have perichondrial cells. The cells that are around the cartilage begin to form the periosteum, and a thin layer of a compact bone begins to form. So let's see how it happens in the endochondral ossification. As you see at the beginning, you have a cartilage. It's completely hyaline cartilage, but it's in a shape of a long bone. Then in the center, these changes happen, disintegrating chondrocytes, and the blood vessels are coming to those new tissues, and then the changes start from these centers. Some outside becomes bony cells like a color around the bone, and finally they become periosteum that has been formed from the perichondrium, has been perichondrium around the cartilage. Now they're changing to the bone cells and become periosteum. And the cartilage cells die and replaced by the osteoblast. As we discussed, an osteoblast begin to form a spongy bone, and this is the primary ossification center that is located in the center of a long bone. Then the cartilage in the metaphysis region is invaded by the osteoblast, and an increase in bone length and diameter begins, like this one. So that was the center. It was the cartilage cells, now has been replaced by the osteoblast, and they start making the new bone here. And as these are rising and just invading to the surrounding, go around until they get to this area of the metaphysis, right? So as you see, the medullary cavity completely have been formed. But still you see that at the beginning, a spongy bone has been formed, and they are eating and moving. Finally, one outer layer of the compact bone remains here, and all the other one thin layer of the spongy bone remains here and here. Then after this, another ossification center starts around the two epiphyses, as we call those ones secondary ossification centers, and osteoblasts begin to migrate into the epiphyseal region, and they begin to replace cartilage on that area with the bone. This results in pushing the epiphysis away from the diaphysis, thus resulting in a longer bone here. So you see that the secondary ossification center, and as you see each area that is forming, the blood vessels are coming toward that one. So these ones again, also they start invading to the surrounding cartilage and replacing them with all those bones. Then pay attention that between the epiphyses, first thing before that, pay attention that we had all here cartilage, right? The whole bone was cartilage. Now this part has replaced by the bone. This is a start replacing by the bone and is completed by bone. That's mostly spongy bone here, but still one rim of the cartilage remains here. This is the one that later, when the bone completes and makes a long bone, the long bones are going to connect to each other to the joints, and those are most movable joints of the body that we call them synovial joint. When we go to the joints, you will see that you have one layer of the cartilage covering this bone, one layer of the cartilage covering the other bones, and they are both taking part in the joint. So pay attention, these are remnants of this cartilage. So one layer of the cartilage remains here because we want to decrease the friction of these two parts when they are moving over each other. And pay attention, all these cartilages are from hyaline cartilage. So, sorry about that, son. So here Besides this one, hyaline cartilage that takes part in the articulation or joint, we call it articular cartilage, that is from hyaline. You have one layer of the cartilage here between epiphyses and diaphyses. And if you take a closer look at this area by looking at the here, this is the side of the medullary cavity, and this is toward the metaphysis here, right? You see the cells of the chondrocytes because it's still cartilaginous, right? So this is a process that the cells from the chondrocyte here, they start becoming and changing to their bone cells, right? The same process that we had it, that the osteoblasts are replacing those chondriocytes, right? So this becomes more bone on the bottom part, in the side of the medullary cavity. But this cartilage also, these cartilaginous cells, as you see here, like has been one cell, now is dividing, making two cells. It means that these cartilage are producing themselves too. They are dividing too. So in this way, the whole thickness of these part, cartilaginous part, it remains the same. From the bottom, it becomes bony, but the cartilage remains the same size and is just moving upward. And this is the way that the whole length of the bone is increasing from the two sides. The bone gets longer and longer and longer, but the whole thickness of these, cartilage part remains the same until it gets close to the end of the growth of the long bone. When it gets closer, the rate of a division for the cartilaginous cells or chondrocytes becomes less and less. And due to that, the thickness of this cartilage part becomes less and less and less and less. And from the bottom, still is continuing to change to become osteoblasts and osteocytes, right? At the very end, you have a very thin rim of the chondrocytes here, and finally, all those ones are become the bone. And that's the one that when all the cartilage from here has gone and they have become bone, that's the end of the growth of a long bone. After that, that bone cannot get longer. So that's the one that we call it the epiphyseal closure. This cartilage is called epiphyseal cartilage, or we call it growth plate, right? Epiphyseal plate, epiphyseal cartilage, or growth plate. This cartilage that we have in the metaphysis area. And when that one completely becomes one line of a bone, we call it growth line. At that point, when you see a line here, not cartilage, means that the closure of the epiphyseal cartilage. We call it epiphyseal closure. And at that point, there is no more longitudinal growth. The length of the bone is not increasing anymore. So that's the whole process. And here you see epiphyseal closure, that the area of the cartilage in the metaphysis forms the epiphyseal line. So whenever you see epiphyseal line in an X-ray, for example, you can say that the growth in that bone has finished. And you can say that that is an adult, is not a kid, right? Whenever you see the epiphyseal plate, that is a cartilage that in the X-ray can be shown as an empty space because the X-ray just shows the bone, not the cartilage. You cannot show the cartilage over there. So you see that there's space between the epiphysis and diaphysis, right, in the metaphysis area. So if you see a space, it shows that it's still a kid and still growing, right? And cartilage near the diaphysis is converted to bone. The width of this one gets narrower as we age. as we discussed, and marks the former location of the epiphyseal cartilage, the time that it was growing. And at the end of the bone is a layer of a cartilage, as we discussed, we call it articular cartilage, over the surface of the epiphysis. As you can see here, this is the articular cartilage, this is a hyaline cartilage has remained here, and it is the time that the whole metaphysis and epiphyseal plate has become bony, and now we call it epiphyseal line, and that is the time that we can say that the epiphyseal closure has happened. And in this picture, you will see the difference between this picture and this one. What do you see? You see, like, for example, in the wrist area, instead of 8 bone that you have in the adult, you still have some bone hasn't been seen because some of them are actually cartilage, so cannot be seen from the inside of the X-ray. What other thing you see? In the long bones, you see that you have a space between the diaphysis and epiphysis. So these are the areas, like here. These are the area of the growth plate here, right? So these ones, when they completely become close, epiphyseal closure, you see that as a line, epiphyseal line. So let's finish this one and we continue this in the second video to continue the chapter 5 regarding the bone and bone tissue.